Can you please type in chat if you hear me? Yes, I can hear myself. Okay, let's start. So, what plans do we have for today? First of all, I have one repository. We make sure that all tests pass. Next step, we look inside repository. We will see how resolvers work. We see which fields are nullable and which are not. Okay, let's start. First step, let's make sure that all tests pass. Okay, let's start the review from the index file. So this is the possible index file you might have. You get the source, you get the variables from the body from the request object, and then you use validate function to trigger depth limit error if it occurs, and if you have, for example, length of that array bigger than 0, that means that the rule is, that means that error occurred, and that's why you return that array with that error. So your next step is to create the context. In that context, you need to place your Prisma, and also you need to place, let's see, you need to place loaders. Something like that. And your next step is to call GraphQL function and pass inside that function your schema, your source, variable values, context value, and that's it. Now let's see how GraphQL schema is constructed. You have the query field, you have mutation field. Let's see how query looks like. You initialize your GraphQL object type. So this first type inside generic is for this parent object, and also you have the ability to pass second type inside generic, and this is the type for your context. So that means that all your context is typed now. Okay, let's see how this resolver might look like. So might look like, yes. You have the member types name, you have the type, which is GraphQL non-null, list, and GraphQL non-null member type. And the resolver for this is like that. Let's see how our member type looks like. We have GraphQL enum type. All fields inside member type is non-nullable. That's correct. And we have something similar inside, for example, user, which have these fields, which are non-nullable. And for example, user also has profile, posts, and subs fields. So let's see how mutations are structured. For example, we have create user mutation. This mutation returns non-nullable user type. That's correct. This mutation also has arguments. We have DTO, which is create user input. This user input is also non-nullable. Let's see how this input looks like. Because this create user input is for creation, we have name field, we have balance field, and both of these fields are non-nullable. That's correct. Also, we have change user input, and these fields can be nullable. Yes, that's correct. So I think that all mutations are very similar, so we will not spend much time. And okay, for example, how delete user mutation may look like. You have, for example, string in the return, and when your resolver will be completed, you just return string, and that's fine. That's also right decision. Okay, так. Okay, let's see how loaders okay, we have, for example, let's start with something easy. Okay, for example, we have posts loader. We also use generics. That first type for generic is placed here. So if you have string there, so user IDs is the array of the string. And also you have the second type inside the generic, which is post body, which is type of post schema. So this schema is taken from REST part. So that's correct. Okay. Okay, we do what? We ask for posts, and also we use where clause, and we have author ID, and author ID should be one of the user IDs. Next step, you make posts map, you iterate through that posts, and you first of all check that this posts map already has key with that author ID. If it already has the key with that author ID, we place posts inside that array. If we don't have the key with that author ID, we create the new array by that key and place array with that post. And our last step is to iterate through user IDs and return the corresponding posts. If you already have questions, you may type them. So we have something similar inside the profile loader, yes. And speaking about these loaders, about subs, we have Prisma call, which looks like that. And as you can see, this Prisma call is very similar to this. So the difference from the rest part is you use in operator, and also you need to join the user subscribe to get the IDs of subs. Maybe do you have some questions now? Is it possible to use schema first and use subtype resolvers? I don't see why you can't, but maybe I don't understand what is subtype. I mean, I can easily use a profile resolver for query profile with the root value object, but I haven't figured out how to implement query user profile resolver that way. So I refactored the project to code first. To be honest, I didn't work with schema first approach, but I think it is possible. I don't. This is very common case to be just not possible. Мой потрясающий английский. Да, вы меня простите. Так. Do you have some questions about these resolvers? If not, we will go next. Okay. So we now understand how resolvers are structured. We now understand how the, I don't know, queries are look like. We know how to, what is the differentiation between non-nullable fields and nullable fields. Again, for example, if we have user have create input, and because it is create input, all fields inside that input should be non-nullable. Also, we have change user input, and the fields inside that input should be nullable. Okay, that's done. Let's check how the loader prime section is done. So we have the users query, and we use parse resolve info function, and we check whether subscribed to user is included inside expected response, yes, and we return the boolean, so true or false. So our next step is to call the Prisma to find all the users, and also we include or note these tables. Yes, it may look like that. And your next step, you check whether is subscribed to user field is included. If it is included, you iterate through the users, you make the single user, and you check this object, and get the subscriber IDs for that specific author. Again, you get the subscriber IDs for that specific author. And your next step is very simple. You just reference to that subscribed to user loader. You call the prime method with key, which is author ID, yes. And also you do what? You make users filter. You make this single user, subscriber IDs include user ID. Okay, you again iterate through that array of users. You take the single one and you check whether user ID is included inside subscriber IDs array, which is that. Okay, and by that you pre-place cache for that subscribe to user loader, and something similar for user subscribed to loader, but in the opposite way. You have author here, you have subscriber here, and there you get author IDs. So very similar. And your next step is just return users, and yes, this is how it works. And yes, that's it. Can you specify what do you mean, but just prime everything? See you, Shiraz. Can you send a link to your GitHub? I just don't see your, I don't see your resolvers. You iterate through users and you make user loader prime user ID and that user, and the user loader okay, it will take some time to understand what is going on. I don't want to spend it right now. Do you have, maybe do you have some overall questions? Okay, if you don't have any questions, I will end stream. Okay, Ilya, I will check your repository. Maybe in 1 hour, something like that. Is it better to use new map for data loaders map? Do you mean that map? To be honest, I don't see any difference. Do you mean, is it better in terms of performance? If you're speaking about performance, I don't think so. No, I don't think so. You have constant time in plain objects and in map. I may be wrong, but I think if you have difference in performance, it will not be huge. But I'm not sure. Okay, I wait for 1 more minute. If I don't see any questions, I end the stream. Okay, as you can see, it performs better in scenarios involving frequent additions and removals of key value pairs. But okay, but to be honest, I just don't understand how it can be possible, because it is just hash table for plain object, and I guess it is just hash table for map. So I just don't understand how just you can get better performance. Maybe I just don't understand something. Okay, good luck everyone in the next task.